Excuse me, sir, I'm lost. I'm looking for a place where I can get lost. I'm looking for a home for my malfunction.
Okay, so number 3, we're going to solve this equation here. We're going to find all solutions, okay? So the first thing is we recognize that this is some kind of cosine times cosine plus sine times sine. So that means we're going to have a cosine of differences of angles. So cosine of first angle and then minus the second angle, okay? And we have that minus sign in between because it would be the opposite of whatever we saw in the middle because we were working with cosine, right? So this thing replaces whatever we had on the left, all of this stuff, and then so we could say this is equal to 1. Okay, and then cosine of, that just reduces to x, is equal to 1. So when is, or at what angle is cosine equal to 1? And we can see on our circle that cosine equals 1 when we're at 0. Okay, so our only solution is not going to be just 0, but it'll be plus or minus 2 pi k. So we can keep going around and around the circle and get the same cosine value, right? So our x is going to be plus or minus 2 pi k. Alrighty, number 4 asks us to rewrite this expression, this 5 times sine of 3x plus 2 cosine 3x, as a single function of this form, a times sine of bx plus c. Okay, so we identify that first of all, we have the same b going on here, b equals 3 for this sine function, and b equals 3 for our cosine function, which means that our period would be the same, 2 pi over b. It would both be 2 pi over 3 for these cases, which is good because we want them to match up. So we already have our b is equal to 3. Okay, we can find our a by taking the square root of m squared plus n squared, where m is the coefficient of our sine, so m is equal to 5, and n is the coefficient of cosine, so that would be equal to 2 in this case. Alright, so a is going to be equal to the square root of 5 squared plus a 2 squared, so that's equal to 25, the square root of 25 plus 4, so that'd be the square root of 29. Okay, so we found our a is equal to square root of 29. Alrighty, and the last one is going to be to find c. That's our last goal here. So we can do so by solving for these equations here. So m should be equal to a times cosine of c, and n should be equal to a times sine of c. Okay, so therefore cosine of c should be equal to m over a. M is 5 and a is radical 29. Likewise, sine of c should be equal to n over a, so that should be 2 over radical 29. Okay, so once we have this, we can kind of just find, well, let's see, both our cosine and sine should be positive, right? So that means we're in quadrant number 1. Okay, so our angle is somewhere in here. Alrighty, and now we can find, we'll just use a calculator for this because we definitely, or I definitely don't know off the top of my head what angle allows our cosine to be 5 over square root of 29 and what angle also allows sine to be 2 over radical 29. So let's solve for those on the next slide. So we have cosine of c is equal to 5 over radical 29, and sine of c is equal to 2 over radical 29. Okay, so what we're going to do is just take the inverse of them, right? So we could actually just work with sine for now. Let's say we just take sine inverse of both sides. So we get sine inverse of sine of c is equal to sine inverse of 2 over radical 29. Okay, so these ones cancel out and we just get c is equal to this thing, which when you plug it into your calculator, you get 0.3805, and then this is kind of like just in radians, right? So that's going to be it. That's our angle here. So c is equal to this thing, 3805. Okay, it's a little bit awkward, but it's okay. A is equal to radical 29, and b is equal to 3. So we can plug it in, and so our expression from the beginning, our 5 times sine of 3x, plus 2 times cosine of 3x, is now going to be equal to a times, so I'll just write it out, a times sine of bx plus c, and we're just going to plug in the values that we found. So we're going to get, this is radical 29 times sine of 3x plus 0.3805. Okay?